Friction problem number 3. Mr. Macheski is speeding along at 30 meters per second in his 1567 kilogram car when he sees traffic at a total stop ahead. He slams on his brakes, locking them up. The mu K of rubber on concrete is 0.8. What is his acceleration? How long does it take him to stop? And what distance has he traveled in that time? Well, obviously we're working with both a forces and a kinematic problem. So let's start by making our kinematic variable list. S, xi, vi, vf, a, and t. And then to find the forces involved, we're going to make a free body diagram. So obviously we're driving along on top of the Earth, so we've got a force of gravity and a force normal as a result of it. He's locking up his brakes, so he is ceasing to apply a force forward, and he is now relying on the force of friction, which is force backwards. So the only force we have applied in the x direction is the force of friction. Great, so let's write those forces down. So we're going to start with our F net. We're going to have one, we're going to need it. F net, then force of friction, then force of gravity, force normal, we have a mass, we have a mu K. Great. And remember, let's just go ahead and add this little guy right here. Our acceleration due to gravity, negative 9.8 meters per second squared. So let's grab our variables out of our problem. So, driving along at 30 meters per second. So we start at 30, VI is 30 meters per second. And then, our mass is 1,567 kilograms. Our mu K is 0.8. Then, that's all we know. That's all we know so far. Except we know 2 other things based on kinematics. Well, we don't have a different starting point, so we're assuming we're starting at 0 meters. And our velocity final, since we're stopping until we come to a complete stop. So we're in the process of stopping. We're going to have a final velocity of 0 meters per second. Great. So, the first thing we need to do is we need to do something to find force of friction. Because a force of friction is going to be our F net. And since F net equals ma, that's going to allow us to find our acceleration, which is what part number 1, part number A, is asking us for. So, F net equals ma. So first we need to know F net. F net is also in this case equal to the force of friction, and the force of friction is equal to force normal, which is equal to negative Fg. Well, force normal times mu K is equal to negative Fg times mu K is equal to, one more time, ultimately negative mg mu K. Okay. And we should have another negative right here. So, we're going to have 2 negatives and positives so that our mg, our g being negative, because the UK is going to result in a negative force of friction. Mouthful. Okay, but let's go ahead and plug our numbers into that. So, mass is 1,567 times the force of gravity, the acceleration due to gravity, negative 9.8, times the mu K, which is 0.8. So we'll go ahead and combine all those, and that'll give us our force of friction. That gives us negative 1,285 newtons for force of friction. Okay, easy enough. So, force of friction, negative 1,285 newtons, and we can use that to determine our final acceleration, or our acceleration throughout this whole motion. So, F net equals ma. F net happens to equal force of friction in this case. So force of friction equals ma, and our mass is 1,567. So F of friction equals ma. That's negative 12,285 is equal to 1,567 A. Okay, let's go ahead and solve that out. That is going to give us negative 7.84 meters per second squared equals A. Great. Negative 7.84 meters per second squared. And that's the first thing we're being asked for. And then the second thing is, how long does it take me to stop? So we're looking for time. Well, we have V on, we have Vf, we have A. We're looking for T. That's our acceleration equation. Let's go ahead and separate out that A is equal to Vf minus Vi over T. And we're looking for T, so we're going to switch these out. So T was Vf minus Vi over A. Let's go ahead and plug in our numbers. 0 minus 30 over negative 7.84 equals T. So our result there is 3.83 seconds equals T. So we'll go ahead and put that in. 3.83 seconds. Great. Then the last thing we're asking is, what distance has he traveled in that time? Well, that's going to be our S equation. So we can use that to find the final position. So S equals xi plus VIT plus 1/2 AT squared. Well, my xi is 0, that'll drop right out. So then S equals VIT plus 1/2 AT squared. S is what I'm looking for. VI is 30 times a 3.83 plus a 1/2 times acceleration of negative 7.84. The negative is important there. And then 3.83 squared. Excellent. Let's go ahead and calculate that, and we'll get our final displacement. And that'll give us 57.4 meters equals S. So, if the cars in front of me are more than 57 meters away, I should be fine. But if not, then I'm going to get in an accident. Isn't that useful to know? Hey, look at that. Thanks, guys.